Hello everybody, my name is Andrei from Think, and today I'm going to show you a bit of one way in which we are integrating LLM agents into Glamorous Toolkit. For those of you that didn't heard about Glamorous Toolkit before, it's a moldable development environment for making sense of systems, data and AI. And now, it's developed in top of Pharo, and it comes with its own graphical stack. So there are multiple ways to integrate an LLM agent into an IDE. One is using an MCP. I will not show you that today. If you want to see that, ping me. We'll show you a different way to directly integrate or call LLM agents from an IDE. And I hope the projector will somehow collaborate. I just have live demos, including with LLMs, so no recordings. So we'll see if everything works okay during this presentation. So first, an LLM agent is an object. So we just can instantiate one, and in this case, I will just have to have a markdown response. We can execute and get the object in the next pane. This is just an object inspector, so we have the agent, the raw view with its implementation. However, the agent object has also a different tool to interact with it. So in this case, it's a chat interface. We could write a message here, or we could send it a message programmatically by sending it send markdown with the markdown content. So we can do that here. Now we have a message, we send it, and then we will get back the result. And in this case, because it's markdown, we can also inspect it and see right in place. Also, here we have two messages. They are also objects, and if we want to learn more about them, we can just inspect the object behind. So for this demo, I'll be using GPT 5.4. We can also connect to other LLMs or to local models like Olama and any other. This is fine. However, in this case was just string. So we send it a string and we got back a string. It's a bit maybe less than ideal. So another thing that we like to do is leverage the fact that most LLM now support structured output. So we can give it a JSON schema and it gives it back JSON matching that schema. And within Pharo, there is a framework called Magritte. So Magritte is just a way to annotate like objects or classes and then use that information to generate things. For example, we have here a class, GT code transformation. I can browse it. We can look in the superclass. And it has, for example, an attribute called transformation. And we are adding a Magritte description that says, okay, this class has an accessor called transformation. And then we can use these meta descriptions to generate, for example, a JSON schema for this class. And also a parser that reads the object from this JSON schema. So here we can start this agent, tell it that as a response, we are expecting also some markdown and also the code, some code transformations. And the task that we're going to give it is to create a class for a person with a first and last name and a print on method. And we don't want it to run the code or make the code in the image, just give us the transformation that we can then apply. So let's create the agent, let's send it a message, and let's see what it's going to do. I will just wait a bit. It gave us something. Before, let's look at what we send it. So we look in the message that we send. We have the output formats. And here we have one for code transformation. And this is the schema that we are sending to the LLM, JSON schema. So we take the class GL code transformation and generate a JSON schema that then we send to the LLM and said, please send us JSON that only matches this schema. And we also send it markdown. So it can send markdown and this. And then in the response model, we got back a JSON, and then we can parse that JSON in two objects. One is a markdown object, and the other will be a code transformation object. Because we don't have to look at the text, we can parse it. And this has, for example, two transformations. And we can also look at them with a different view. So in this case, we can see that one adds a class and the other adds a method. And we could then accept the code here and continue. And then also interestingly, we get the same views also in the chat interface. And this is exactly the same view. So the way the chat interface works, every time you get a response object back, it looks at the views of this object. And if you look at the source, this view has an extra annotation, GT-LLM view. So it takes all the views that have this annotation from the response objects and adds them to the chat interface. So then the chat interface is more dynamic. As you get responses from the LLM, you get different views depending on what the LLM is returning. It's not always the same standard chat interface. Okay, let's do something more interesting next. Up to this point, we just use the basic chat. So if I inspect this chat, it has no instructions. So it's an empty thing, just plain GPT chat. Let's try to give it a task. So we like it to provide the rewrite rule for removing all self-halt statements from methods. So this will be a rewrite rule that if we run it, we'd expect it to remove all the self-halts. We still give it no knowledge whatsoever. In 95% of cases, it gets it wrong. We'll see if the demo gods are with us. So refactoring browser is known a bit. Got it semi-correct in this case. So better than expected. But then one way to further improve this is to give it more details about the task. So give it like a system prompt. So the way we do that in GT is that in GT we have a book. So it's called a GT book, which is in the image and is written in Lepeter. This is our documentation syntax. So it has over 600 pages of documentation available in the image, and one part of that documentation is about rewriting Pharo code. So this, for example, it has some explanation, some methods, some example methods that show how to do various things about rewriting code. And what we can do now is open an agent and tell it that we want to pass it this page in the explanation. So any page that we have, any Lepeter page that we have as explanation, we can pass it to the engine. And now the instructions is going to have a flattened version of that page. So for example, before this was a method, but we take the code of the method and we embed it. And we can also do that recursively if needed. So we try to create a flat piece of text that we then give to the LLM. And now if we try the same, in this case also before it got it pretty correct. Let's see. Okay, it's a bit better now. So actually, this is what I would have expected. So we can run it, but now if we run it, yeah, we just get the object. It didn't do anything. It didn't do the rewrite. So we still have to manually do more work. However, we can also rely on the fact that we can have this custom response objects. So here is just Markdown. But why not tell it to give us something more, an object? Why just Markdown? So next, we could tell it that we have an object, it's called a rewrite rule. So we could tell it, hey, don't just send Markdown. Please also send us the rewrite rule that we can then apply. And this rewrite rule is again a class that has those Magritte descriptions. So it has like what's the pattern to match, what's the pattern to replace with, and a few other information. We can run it. If you look at the message that we send, we have again the format, so we tell it through a JSON schema how does this rewrite rule look like. And then we get back, for example, response models, and now we have a rewrite rule object. And because it's an object, we can have a view that shows the rewrite rule in a different way. And we can also show it in the chat because it has the same annotation. So we take it and show it in the chat. And then we can also run it from here if we want. So this is going to run this rule against the system. We can apply filters if we want to just run it in certain packages, classes, or whatever. And then we can also run the second. So this is the pattern to replace this one. So it just removes the halt. So if we want, we can do that. And now we get a refactoring that replaces the halt, and if we want, we can accept, reject some of them, and continue. So again, if we ask for more complex data, we don't necessarily have to get back a JSON that we manually deal with. We can ask it to return an object, and then have a view through which we can interact differently with that directly within the chat. Now, all these agents were like one shot. We sent something to the agent, we got back an agent. However, the real power of agent is coming when we are able to use tools. So we are able to allow the agents to call back within our system. In this case, we're going to start an agent, give it some tools and the task. For these tools, we'll just give it some tools, for example, to search through documentation and classes. So like search for classes, search for Lepeter pages, and we're just going to give it a simple task to just to see how this works, to try to find what this class is about, and if there is some documentation about it in the book, in the GT documentation. So now, ideally, the model, because it had tools, should call back. Often this is a black box of what it's doing. However, in our case, we wanted to also see a bit what the LLM is doing live. So now in the interface, these are all the tool calls that the LLM does back it in our system. So if you want to see, we can expand it and see it. Search for this class first. It search for some Lepeter pages. It search for references to this class, RB parse tree rewriter. And if you want to see what it returned, we can inspect it, and now we get a tool message, and this will be the, for example, this didn't return anything, this returned, it searched for deprecated for some reason, then it decided to get the code of this method, which was this, and also interestingly, if sometimes you want to see what data is the LLM return, what data is being returned to the LLM. Sometimes it might be interesting. So for example, the message JSON, this is exactly what LLM sees based on this tool call. And this is actually just this list of methods here. So we can also load the JSON or have a different view to interact with this kind of data. It looked up for more classes, and at the end it gave us some explanation. So it was able to query the system, find it, and then we can always see the trace of how the LLM called back into our system to answer this particular question. So this means that in our previous question where we asked it to remove the halt, we might not have to give it specifically that piece of documentation, because before we gave it a page to look at. But now we just tell it, please look in the book, find something that's relevant to us. Just try to see if we can find that page that was explaining how to rewrite rules. We gave it again the tools to be able to search, and we tell it again, we want a rewrite rule object back, not just markdown. And now it's going to do some queries. I don't know what it's going to do. Every time is a bit random. So it searched for some Lepeter pages, and then it decided to get the content of a page. Okay, this is not our page, so it didn't find the right one. It's searching for more Lepeter pages, even more. So it goes, and then it gives us something, and in this case it failed, unfortunately. So it's a live demo, so it doesn't all the time get it right. 95% of cases it's right, but 5%, I don't know what path it takes, and it's no. So some cases, yeah, it can be good, some cases it can be wrong. Well, let's try again, just to make it work, maybe. And if not, we move to the next one. So in our case, we'd like to use Lepeter pages more like skills in other, like in Cloud Code. So try to describe what we want there, and then see if we allow the LLM to find this information and how accurate it is. In this case, it seems today it doesn't want to find it, but it's fine, we can move on. Now, up to this point, all we did was looking at static code. But the very interesting thing about a live environment is that we have objects. And we should be able to look at those objects, interact with objects, and allow also the LLM to do that, not just us. The system is mostly about live objects, not about static code. So let's try a demo where we're going to try to work a bit with objects and answer some questions. For that, I will use this script. So this is a task that is asking the LLM to generate an icon, just an icon of a house, and then assess how good that icon is by inspecting the object. So it's going to generate a graphical object that represents an icon of a house, and we want it to look at that object that it generated visually, and then say how good is, grade it on a scale from 1 to 10. So let's see if that is going to work or not. We're going to give it all the tools from GT. So also we are going to allow it to execute code if it wants to. So it's working. Now it should have some tool calls. First, we gave it also an example method just of how another icon, so it can find this. Now it executed some small talk code. And then it looked at an object, at a view of this object. We'll see a bit later. And then it gave us the results. So in this case, we just told it we want markdown. And it's a script, and it told us it's 8 out of 10. Okay, we could execute it, and this is the house that it decided to generate. Yeah, this is the code. But more interestingly is to look at these tool calls here, to see, for example, how it decided that this is a 8 out of 10. Because how did it visually look at this house to decide that it's that? If we inspect, for example, the Smalltalk code execution, so this is a tool call that gets this code and returns to the LLM an actual object. Now, all the objects that are returned from tool calls to execute are also stored by the chat. So the chat has object storage where we can place objects manually if we want the LLM to access them, or all the results of the code execution are also placed there. So the LLM can also access objects that it created or the ones that we gave it. And here we have this object. If we look at it in an inspector as humans, we'll see, okay, it's an object, it has a title, it has some views, it has a raw view that shows us the implementation, it has a meta view that shows us some details about the class. And as much as possible, we'd like to allow the LLM to look at objects pretty much the same as we do, like inspect them through views if possible. So in this case, to see what the LLM actually got back from this tool call, we can look at the message JSON, but this will be a bit too long, so we just look at the dictionary. So this is the message JSON, message data that represents the dictionary that we send back. And here we first send some text, so this is just some details about the object. So we give it the ID to know how to call this back, the ID from the ID of the object from our chat. We gave it all the instance variables, so a print like the raw view. These are the instance variables and these are their values. And then it's an inspector, so we also give it all the views. So what are all the views of this object in the object inspector? So then if it wants, it can also decide to look at views later on. Why not? We do the same as humans. We look at the views in the inspector. And then in this case, because this is a graphical object, so if you look, it's a house. It was, where was it? This was a, yeah, it's a graphical object, it has a graphical representation. For this object, we can also send back a second piece of data. With this case, in this format, it has to be an image URL, which is the base64 encoded PNG, but we can have another view. That this string represents this base64 PNG encoded data. So now for this graphical object, the object actually decided to send back to the LLM two things. A textual thing saying what are the attributes of this object and its views, and then also a graphical representation. So now the LLM will also know how it looks like. We'll not just have the text. We'll not have to guess. So any object can decide to send any data to the LLM. It can choose. And if we look at the third call here, this is one that says get view content. On this, so if you look at the arguments, it says I have this object with this ID, and please give me the view that's built by this method. So like this, the LLM can choose to look at a specific view of an object. So not just the raw view, because this object had some views. It can just choose, I want to see this one. And in here, it decided to look at the preview. So we have the source code here, and this is what it sent. And if we look again in the raw data that it got back, for this view, we also send some text information. In this case, we send the source code, that its title. And since it's a visual view, so this view is visual, it's graphical, like before, we also send how the view looks visually, which in this case is the same house. Could have been differently for other views. So like this, we want to allow the LLM to not just look at text, be able to create objects, and like we humans look in an object inspector at views, also allow the LLM to reason about objects through views as much as possible. So then it can also decide what information is relevant and not load everything. Just step by step, try to look at individual views. Now let's try to do a bit more of a complex development task. Till now we didn't really generate that much code. We were just doing calls. So for this demo, we're going to use some GitHub data. So we're going to make a request to GitHub to give us the ThinkCom data about the ThinkCom organization. We're just going to get a string. We will parse it now into a dictionary. And then we're going to create an object out of it. So in this case, we just have a GitHub organization object. And this will show us the list of repositories from the GT organization. We can choose a repository. And this is the GT repository. We just see its basic data. And what's interesting and what I would like to know more about it are the issues. So I see there are 320 issues. But now we'd like to extend this with exploring the issues. So for that, I would like it, let's say, to generate an entity representing an issue, add a way to the repository to extract the issues, and maybe show here issues view with a list of issues. For that, Again, we don't have to go to the chat somewhere else. We can start the chat here. One way to do it would be to open the playground and do it programmatically. So we could say we want a chat and say that we want to add an object to the storage to be the current one. However, we don't have to do it necessarily from here. We have an action. Always, every object has an object as an action that says, I want to start a chat about this object next. Please add this object to the storage and start me a chat about it. But now if we do it and we look in the storage, we can see now the LLM is going to get access to the object having this ID. So it can reason about it. I will copy the task I wanted to give it so we don't lose time. And I can paste it in the chat. And all it says, extend the repository object that you have in storage with the logic for computing the list of GitHub issues attached. Ask it to create an object for this, add some views to this, and then add some examples in a different class, more or less. So it's task. Should do it in a reasonable time for this demo. We can start it. Now it will be a longer history. Okay, first it actually looked at the object from storage, which makes sense. Then it looked at this class, which also makes sense. So like this, we can track live if we're interested what is happening here. It looked for packages. So it's going to think maybe for around a minute or so, if the demo goes correct. It still didn't compile anything. So it's just, for example, getting the code of methods. So it looked at the code of these methods. Likes to look at assert equal. Now it created, so it created at least some classes. So it created a isug, GitHub issue, and GitHub entity examples, okay. And then it compiled methods. It compiled 11 methods. So we also have a view to show the diff between what existed before and what is now. So this is what this tool call did. In this case, everything is new, so there is no old content. There is just new content. Also run examples. So we decided to run one example method, another one, and another one. So these three passed. And then it actually looked at a view. It created a view, and it looked at the GT issues for view, which was maybe one that it generated. And it's still running. I guess it still needs to do some things. And it's done. Done very nicely. And now if we look at what it tells us, okay, it also tells us some explanation. Okay, good. If we look in the storage, okay, it has more objects, so it did more small-to code executions that created objects that it placed in the chat. In the storage, this is our initial object. And we can see it has now a list of issues. And if we look at an issue, it added this raw data view. So it actually created, if you look at the source, let's see what it created. It created this, it created the issues method, and it found how to parse the issues from GitHub. I don't know, it figured it out. And then it created this class with this method, so not that complicated. But what's interesting is if we want to reason, let's say, if you like to reason a bit more about what happened in this tool call. One way would be, okay, we can look at its explanation, but yeah, maybe here to just give us a highlight of what it did. We could look at its tool calls, but yeah, if this can be a lot long, so maybe we don't really always want to look at everything. So another notion that we have in GT for the chat is that of summarizers. So a summarizer is an object that is applied on a message or on a chat and can extract some relevant information from it. Anything can be, like the tool calls. And here, one interesting summarizer is going to show us the list of changes that happen in these tool calls. So it's going to take all the tool calls, find all the changes, and just give us a summary of this is exactly what changed. We don't have to necessarily go and read the markdown of what the LLM said, because here that didn't tell us actually everything that changed, all the methods. But we can actually see everything that changed through a summarizer. And another one, for example, is the list of examples that were run by this LLM. So in this case, we see it did 3 calls to run examples. And in its case, it just ran one example and it passed. And then here, summarizers are at the level of a message. However, we can have also summarizers at the level of a chat that take into account all the messages that this agent did, if this is what we care about. So like this, we can have a conversation with the LLM and have summarizers that extract various relevant information that then we can look at, that are more predictable than just asking the LLM what it did. And finally, as I'm approaching the end, let's say we want to do some other task. Maybe we want to expand a bit one of these issues. We don't have to do it in this chat. We can just discard this chat. Chats are, we can spawn them as we need to. So maybe I want to look at this issue. And now the chat is gone. Now I'd like to do a task on this object. Maybe I will start a new chat on this object. And now here I would like to see how this one looks actually, because I don't see how it looks like. What is this? What is the content of this issue we're missing? So I'd like to tell it to create us a view to show this issue. And in this case, I will just copy the text. So I wanted to have a web view. So just embed the web browser here to show us. So I just told it to create a web view showing the page attached to this GitHub issues using a web view. So it's going to think maybe for 30 seconds if the demo is right. It found the class GTWebViewElement. It's looking for methods, looking for classes matching examples. And still thinking. It's not going to think for long. It created something, perfect. Why did it create a class? I don't know. It compiled two methods, and now we appear here a view. So it added a view. So now if we look at issue page, unfortunately it failed. So not all the time it succeeded, but did it figure out that it failed? Yes, so it figured out that it failed actually. This was not part of the demo, it just happened. So it tried to get the content of the view, and it got an exception. So we also send it the exception. So then it compiles something else. I have no idea if it's going to fix it. It fixed it. Perfect. It actually worked. So it managed to create a view where it shows us this in a web page. So that's nice. So it actually found the problem, got the view, saw that there is an error in the view, got the stack trace, and then compiled and managed to fix it. So yeah, so that's all that I wanted to show you about how we integrate LLMs within GT. And as a takeaway, so in GT, we treat the user interface more as a language that is not fixed, but is composed of a set of operators like views and repeater pages that can be combined. And when we integrated LLMs into GT, we didn't want to just have a fixed chat that's standalone from the rest of the environment. We want it to be more like an operator that can be freely used whenever it's needed and in the context that it's needed. And then with these views, for example, as humans, when we look at an inspector or even to understand our system, you use views and repeater pages to document. So we wanted the LLM to do the same. So in this case, views and repeater pages are becoming kind of skills that the LLM can load it to its context as it's needed, as it's exploring our systems and our objects. If you want to know more, the GT book has a tutorial on agents. This, what I showed you, it's a bit part of this tutorial. And if you want to know more, you can just download GT and have a look. That was all. Thank you.